Hey Calc, let's take a look at a lesson on piecewise functions. So piecewise functions are several functions, okay, that are pieced together. Several functions that you put together, but there has to be restrictions, or they have to tell you when to use each piece. Okay. Please note that numbers will only be allowed into one piece of the equation. So if you look at this first piecewise equation, the equation is actually this downhill line if your input values are less than 1. So if you have a number less than 1, like 0 or all the negatives, then you'll use that top piece. But if you have numbers that are 1 or greater, okay, then you're going to use this parabola piece. And so it'll always tell you which piece you're supposed to use, so you know how to evaluate it. Okay, f of -2. So since that's negative, we're going to go ahead and use this top piece up here for x's that are less than 1. So we're going to do -2 plus 1, and the answer is going to be 3. -1 needs to go into this top piece again. So a -1 is 1 plus 1, and out comes a 2. It's really just making sure you use the right piece. If you are 0, we're going to use this top piece again, and that's going to give us a value of 1. Now, where are we going to go for a value that has an input of 1? This top piece is only less than 1, not equal to 1. This bottom piece has the equal sign, so we're going to put 1 into this bottom piece. 1 squared plus 2 makes a 3. 2 is definitely the bottom piece. 2 squared is 4. 4 plus 2 is 6. 3 is going to go into this bottom piece. 3 squared is 9 plus 2 makes 11. Okay. What is the shape of the graph for the numbers that are more than or equal to 1? Okay, so that would be this bottom piece right here. For numbers that are greater than or equal to 1, the shape of this graph is a parabola. And what is the shape of the graph for the numbers that are less than 1? Okay, so that top piece, if you're less than 1, this is a line. This is a line, okay? This line would be going downhill, a downhill line. And this parabola, since it's positive, okay, would be opening up. Okay, so it's just a couple of equations to look at. You could also evaluate piecewise functions by looking at a graph. You could see here, okay, how something happens right at this value. If you'd like, you could go ahead and kind of draw like a wall, just a dotted line, not part of the graph. So something is happening at -3. Okay, if you are left of -3, you're the parabola, but to the right of -3, okay, you're definitely the line. Okay, so this side over here is the parabola. And then everything to the right going this way, okay, is the line. The question is, what do you do at -3? Which function do you use? Okay, you can't use both of them. It can't have two answers. That wouldn't be a function. Okay, so since that's open, it's not being evaluated in the parabola. It is being evaluated on the line. Okay, so f of 3. Let's color code this. F of 3. So all x values more than -3. So 1, 2, 3. The output is 1. What about -7? Let's switch colors here. -7 goes to the left. -5, 6, -7. Right there has the output of 0. How about input of 0? 0 goes in, and 3 comes out. That's on the line. Ooh, 9. 9 is on the line, and the output is -3. What about -3? Is there a solution? There is. It's up here. It's on the line, and it has a value of 5. It's kind of like just evaluating with information off a graph, but the graph might change shape and have a couple different pieces. Okay. We could also evaluate. We can evaluate a bunch of things looking at a piecewise equation. Okay, so when you have a three-piece, you just have to make sure you really look at these domain restrictions. Okay, so the first piece is for numbers that are less than or equal to -2. So you would want to use this line equation if you're less than or equal to -2. So I'm just going to go like this. Okay, all of these values here, we're going to use the f of x that's equal to x minus 3. If you are between -2 and 2, -2, so not including -2 and not including +2. So if you are inputting these x values, okay, then you're going to be using this parabola equation. So f of x would equal -x squared plus 5. And then finally, if you have values that are greater than or equal to 2, so all of these right here, then we're going to be using this other line, f of x equals x minus 4. Okay, so now that we've kind of organized our thoughts, let's go ahead and input the values. -4 minus 3 is -7. -3 minus 3, -6. -2 minus 3 is -5. Okay, and now there was a breaking point. So -1 is going to go into that middle piece. You just have to make sure you evaluate in the right section. And the way this would work is negative. The input has to get squared plus 5, and the input is -1. So that becomes +1. Then we have -1 plus 5, and that comes out to be a 4. Input 0, get a 5. Input 1, get a 4. So let's switch colors. And now we're going to use this last piece. 2 minus 4 is -2. 3 minus 4, -1. 4 minus 4 is 0. Okay. Let's state the shapes of graphs. Okay, so what we're going to do eventually is graph all these different pieces, but for right now, we just want to state the shapes on the graph, like in the right sections. Okay, so what I'm going to do is, maybe I'll get out a pencil, and I'm going to draw a border line. So if you're less than -3, you're something, and if you're more than -3, you're something else. Okay, so I'm just going to draw this little wall right here, okay, separating the graph into two sections. Okay, so if you are less than -3, okay, the graph over here is going to be a parabola. And then if you are more than -3, okay, so this entire section here, this is going to be the line, this entire thing right there. And what happens at -3? Are you the parabola or the line? Yeah, you're going to be neither. There is no value where the -3 would go in. Okay, let's do a triple. Let's do a triple. So maybe I'll build those walls again. At -2, -2. Everybody less than -2. Let's just build the wall. If you are less than -2, you are going to be an uphill line. Uphill line. I'm just going to write uphill. So when I go to graph it, I make sure it comes out correctly. I should have put uphill over here. Uphill line. Just some details, right? This parabola would be opening up. Parabola opening up. So in case I go to graph it and it comes out upside down, oh, wait a minute. This middle section right here goes from -2 up to 3. Okay, so let's just build a wall. So this middle piece right here, okay, would be using this equation, and this is a parabola. So this entire section here is a parabola, and it would be opening up. It would be opening up. The vertex of this parabola would be what? Yep, 3, -7. And then there would be one transformation. What does that 2 mean? That's a vertical stretch of 2. Okay, so we are going to use all our transformation techniques when we go to graph that parabola, but we'll do that tomorrow. And then finally, this last piece right here, if you are more than or equal to -3, you are going to be a cubic. The cubic will be opening up. Opening up. What's the vertex? What's the vertex of that cubic? -4, 1. Okay, so when we go to do these, we'll have 3 different little pieces, and it's not the entire cubic, just a part of him. We'll have to chop off the rest of him and just keep a piece of him. Okay. Something that we're going to have to be able to do, okay, is find the starting ending points for each piece. Okay, so we're not going to use this entire line. We're only going to use the line that's less than -2. Okay, so what we're going to do here is get good at finding the starting and ending points. Okay, so we're going to take -2, and we're going to plug it into the line. If I have 3 over 2 times -2, the 2's would cancel. -3 plus 7 makes a 4. Okay, so even though I don't use -2, that would be an open bubble, but that is where it ends. Okay, so we end up having this line that goes all the way to the open bubble point, -2, 4. Okay, so you just take these values, you plug it into the piece to find the actual point. All right, when you have something like this for this middle section, we're going to have to do it 2 times. 2 times. So it's a parabola opening up. Okay, so the parabola opens up like this. And since this is less than and this is less than, these are going to be open bubbles. But what I want to know is where these bubbles are. Okay, so what we're going to do is we're going to plug -2 into the equation to get that point. And then 3, something, let's get that ending point, the starting and the ending point of this piece. So if -2 goes in the equation, -2 minus 3, -5 squared is 25 times 2, 50. 50 minus 7 is 43. Let's take 3. 3 minus 3, 0. 0 times 2 is nothing, and we get -7. So the starting point and the ending point of this piece are right there. All right, let's do it one more time. Okay, so we've got this cubic. We've got this cubic that starts at -3, and then it kind of keeps going. Okay, so how do you find that point? You just take the value of 3 and plug it in. 3 plus 4 is 7. 7 cubed, oh my goodness, 7 cubed plus 1. Let's get some help. 7 cubed plus 1, what does that make? 344. Okay, great job learning piecewise pre-calc.